So now today the discussion will be on SN1 and SN2 mechanism first, followed by other reactions. SN1 substitution nucleophilic unimolecular happens with a carbocation intermediate, and SN2 reaction happens preferably in the non-aqueous medium. That is the difference. SN1 favors polar medium, or in the other way we can say polar medium will improve or enhance the SN1 reaction, whereas SN2 reaction is performed in a non-polar solvent. Hey, all of you take pen paper and write it down. Whatever I am telling, write it down. It is called effect of solvent polarity. Write down effect of solvent polarity on SN1 and SN2 mechanism. Effect of solvent polarity on SN1 SN2 mechanism. এই তোমার খাতা পেন কোথায়? জলদি বার করো, গল্প করার জন্য আসুন এখানে। Effect of solvent polarity on SN1 and SN2 mechanism. Write point wise. Polar solvent enhances or accelerates SN1 reaction. Polar solvent enhances or accelerates SN1 mechanism. SN1 reaction will be accelerated by polar solvent. Am I clear? SN1 reaction will be accelerated or promoted by polar solvent, whereas SN2 reaction will be preferably done in your non-polar solvent. SN2 reaction will be preferably done into a non-polar solvent. Non-polar solvent favors SN2, polar solvent favors SN1. Why it is so? Because SN1 means carbocation, which is stabilized by polar medium. So SN1 reaction is favored in a polar medium because carbocation is generated, which is solvated by polar solvent. But SN2, there is no carbocation, and so the role of polar solvent not there. Not only that, it will retard the reaction. SN2 reaction will be retarded in a polar solvent. Why it is so? Because SN2 reaction occurs. How does it occur? Just think over. Your one nucleophile is entering the molecule, and one nucleophile is going out of the molecule. And during that process, the polarity is delocalized. Beforehand, suppose OH minus is there, but when the reaction is going on, transition state, OH minus will have delta minus charge, and Cl minus will have delta minus charge. If you take alkyl halide and OH minus, in that case I am telling, when the OH minus is entering and Cl minus is going out, there OH minus and Cl minus both will carry half charge. Okay, charge is getting distributed. That is favored, not at all favored in polar medium. That's why reaction is retarded if you give polar medium. Reaction will be retarded. Okay, so polar medium will facilitate SN1 reaction, but not at all SN2. SN2 will be better into non-polar medium. Is it clear? SN1 reaction happening like this way. This is the carbocation. Now this carbocation is stabilized by polar solvent. This carbocation is getting stabilized by the polar solvent. This R plus I am talking about. This is a carbocation getting stabilized by polar medium. Okay. Now, if you take SN2 reaction, so this is called the solvation effect. See here, R plus getting surrounded by water molecules, forming hydrogen bonding. So this is, we can call ion dipole interaction also, because this is a dipolar molecule and this is an ion. So ion and dipole interaction. So it's ion dipole interaction. There are some interactions like dipole-dipole interaction, ion dipole interaction. This is one of them. Ion dipole interaction. D by force, schism force. Have you heard about D by force, schism force, Van der Waals forces? So it is falling into that. Van der Waals is a general name of a scientist. Van der Waals cannot be a force. Van der Waals is a scientist. So Van der Waals force includes different type of forces. One is called London force. That is instant dipole interaction. And it happens into non-polar solvent or non-polar molecule. In case of non-polar molecule. If it is a polar molecule, normally we face dipole-dipole interaction. Okay. And if ion exists into the solvent, then ion dipole interaction. That is the example is here. Okay. So these all are called Van der Waals force in general. So Van der Waals force is a general term. And these are specific terms, schism force, D by force, these are some specific terms. Okay, ion dipole interaction is a type of force, dipole-dipole interaction is another type of force. These are all together called Van der Waals forces. So here we are getting some sort of Van der Waals force, ion and dipole interaction, making the carbocations stable, and that's why the reaction is obviously facilitated here, enhanced. Reaction rate will increase, improve. Okay, so R plus is going forward by this solvent, polar solvent, that is water. But if you take SN2, I'm going to another slide, that is particularly SN1 and SN2 mechanism. Specifically, this is for SN1 SN2 mechanism, reaction mechanisms. So SN1 mechanism, as I was discussing, see this is the animation. It will make the thing more clear. So first of all, the molecule is going out, the red color ball, that is the leaving group, that goes out. Then the entering group comes in. So it can come from the same side or it can come from the opposite side, because when the molecule is becoming planar, so there is equal and opposite, that both sides are open. Now the attack can occur from the right side or from the left side, and equal possibility. That's why 50-50 DL product we are getting. Okay, stereochemistry if you consider. So we are getting 50-50 DL product. That is called racemic mixture. Okay, 50% D, 50% L. These things already I have discussed earlier. So the reaction is like this, and it is the SN1 reaction factors affecting the rate. What are the factors affecting the SN1 reaction? Two factors. One is with which the leaving group leaves. That means the leaving group, standard of the leaving group. How is the leaving group behaving? Is it a big one, large one, charge? How much is the electron density? So mainly size. Okay, mainly it is size. Now the stability of the carbocation. Leaving group size, I is large size, that's why it's leaving so easily. And entering group is also another factor, entering group. Okay, but that enters, that also matters. If it is a large entering group, that can easily enter. So you can think, okay, it is a big one, so there will be too much of steric crowding. Yes. But no, it's not happening, because it is doing the reaction from a long distance, deforming itself. If it is a large one, it can deform itself quite easily. Like I minus can deform much more easily compared to Cl minus. And Cl minus will be better than Br minus. I'm telling wrong. Br minus is larger, so Br minus will be better as an entering group as well as leaving group. I minus is the best, then Br minus, then Cl minus, then F minus. If you take the series. Okay, because of size. The larger the size, more will be the deformability. It can deform itself. So it can, when it can deform itself, so it can enter easily as it can go out also easily. Language open. So leaving group and entering group, both if you consider both, then I minus is the best one, then Br minus, then Cl minus, then F minus. Okay. So that is the increasing reactivity is written.
How to know that a substitution will happen?
How to know substitution will happen? Okay. So, for example, I can give you some idea. If you have RCl, if you give NaI, then substitution will happen. If you have RI and you are adding some NaBr, substitution will not happen, because larger one can replace the smaller one cannot replace the larger one. This is called Finkelstein reaction. The big one can replace the small one, but small one cannot replace the big one. It's very simple to understand. Now this one, the second point, stability of the carbocation. 3 degrees more stable compared to 2 degree, 2 degrees more stable compared to 1 degree. Why? Because of plus I effect. 3 degree means with carbon, that carbocation, there are at 3 different alkyl groups present. Methyl, methyl, methyl. 3 different alkyl groups are present. So all are giving plus I effect. So plus I effect means what? Donating some electron towards the carbocation. So carbocation is electron deficient. So if it gets some electron density from other sources, so it will become, obviously, it will become happy situation. So that can easily be formed. But if you have 2 degree, it is getting only plus I effect of 2 alkyl groups. And if it is 1 degree, it is getting the plus I effect of only 1 groups. The more the number of alkyl groups attached to the carbocation, more will be the stability. Like this. Already is given, drawn nicely, just see. So plus I effect of 3 alkyl groups, 2 alkyl groups, 1 alkyl group, no alkyl group. So obviously the stability order will be in this direction. So this will be most stable, lesser, lesser, lesser. This is the least stable. Then this has got another possibility. If bromine goes out, just think. If this is the molecule, what is the molecule called? Allyl bromide. This molecule is called allyl bromide. If the bromine goes out, you get allyl carbocation, which is resonance stabilized. Okay, so resonance stabilization factor is stronger than inductive effect. Resonance stabilizing factor is stronger than inductive effect. So if we consider all the effects, resonance is the top priority, then second one coming inductive, then coming hyperconjugation, then solvent stabilization. Okay, but sometimes solvent stabilization can come upper also, depends on the quality of solvent. Okay, it can come in the third category, and sometimes the inductive effect can come to the top because resonance is not good. So resonance does not mean if you draw certain molecule, that does not mean it will be always possible. Okay, so you have to use your common sense, chemical sense, I mean. Okay, chemical sense, I'm using the term. So what does it mean? Yeah, chemical sense. What does it mean? Vacant, you have a concept of vacant orbital, you should have a concept of lone pair, vacant orbital. So if you can apply these senses, you will understand that you have got some chemical senses. Okay, so just like you asked, so which one can replace which one? Size. Larger can replace smaller, smaller cannot replace larger. That is also chemical sense. Why? The molecule is getting elongated, and from a longer distance, from away, it is starting the bond formation. Starting the bond formation from a larger distance. So as a result, what will happen? The barrier will be smaller, because you are always supplying some amount of bond energy. Bond energy is generated, that bond energy is already generated. So that's why crossing the barrier will be easier. Suppose you have a hurdle, you need some money. Okay, for some admission or something, you need some lump sum amount of money. If it is supplied by some sources, like you have mutual fund, you have different monetary sources, you are getting some amount of money. It will be helpful. So here is also like that. It is becoming helpful. Some amount of energy is supplied, it is coming out because of partial bond formation. From the longer distance, the bond is already being formed, and some amount of energy is getting released. So molecule is accepting that energy immediately, grasping that. And by grasping the energy, it is going ahead. It's becoming facilitated. The reaction is becoming easier. Crossing the barrier will be easier because it is getting the activation energy. That's the thing. So with the large one. But the small one, it has to approach very close to make the bond. That is difficult. That's why from a longer distance, large molecule or large ion can start the bonding comparatively easier way.
Sir, can you explain that again?
with some photo picture. Okay. So suppose this one is F1 and this one is I minus. Now this one can be elongated much larger compared to this one. That's why the bigger one from a longer distance can start forming the bond, which is not possible for F minus, but is becoming possible for I minus. It is much more flexible because of larger size. So starting the bond from the quite longer distance away from the molecule, the reaction is getting started by deformation. Okay, now in this case, allyl bromide, it is forming carbocation quite easily because of resonance. Here also, if the plus charge is generated particularly at this carbon, it will undergo resonance. It is called benzyl carbocation. Again, resonance stabilized, so it will be quite easy. So SN1 reaction will be performed. SN1 reaction will occur. So this one already I have shown you earlier. So let's go ahead. Yes. So this is called energy profile diagram for SN1 reaction. So this is the reactant. This is called tertiary butyl bromide plus HOH means water, but practically we can have some OH minus also. But here actually reaction is not happening. This is the aqueous medium. This HOH indicates aqueous medium. It is not a reactant here in this case. Okay, aqueous medium we are using so that the carbocation can be formed. Without the aqueous medium, carbocation formation will be difficult. So that HOH means water we are giving, that's an indication that carbocation will be formed. Now it is forming the carbocation, so this is the polarity generated. This polarity is due to the polar solvent only. Then after that, the bromine goes out and you are getting the carbocation. Here, this is the intermediate state and this is the position of the intermediate. Here is the reactant, here is the barrier, first barrier. Then you have got the intermediate position. Then after that, second barrier, which is smaller. This is larger barrier. Why larger barrier? Because breaking the bond is difficult. It is endothermic. Now the bond formation is taking place in this case. This OH2 is coming in. Obviously, it is some alkaline solution. So OH2 as well as in OH minus and both can attack. OH minus can attack or H2O can attack. Both the possible. Because once the carbocation is formed, it is easy to attack by some nucleophile. Now water is also a nucleophile. Water is also a nucleophile. So water, we can show water reaction also. So H2 is getting added. So and after that this is going out. Okay. So and you are getting the product. So product is energetically lower. So this is energetically higher, this is lower. So ultimately you are getting some release of energy, that is delta H negative. Delta H negative. So this is called thermodynamically controlled product. When thermodynamics is signifying, yes, the reaction should happen. And if the reaction is happening according to thermodynamics, according to our expectation in thermodynamics, if the reaction happens, we call it thermodynamically controlled product. Because here del G or del H, both are actually indicating, yes, the reaction should happen. And is happening. Okay, so that is called thermodynamically controlled product. But sometimes what happens, the reactant is crossing the barrier and coming down somewhere around here, but could not come back because it is quenched. Quenched means reaction is stopped or barred by some means. It is stopped by some means. Usko band kar diya. So it cannot go back. So you are getting the product. Though the product is less stable. Then it is called kinetically controlled. It is called kinetically controlled. Now here is the animation of this thing, that what is happening actually, how the carbocation formation is happening. The same thing is actually explained here. Now stereochemistry of this SN1 reaction. So once it is becoming planar, attack can be from right hand side or left hand side. If it is happening from the right hand side, you are getting this inversion product, and if you are getting from the left hand side, you are getting retention product. So and it is 50-50, so we are getting DL pair, and 50-50 DL pair is called racemic mixture. Racemic mixture, and it is optically inactive due to external compensation. These keywords you must write. Don't forget. That's why better to write down. Okay? Do you remember all this? If not, then write down. Racemic mixture is 50-50 DL pair and it is optically inactive due to external compensation. These are the specific terms required. So this is the product. In this case, we have taken a bit larger molecule. Okay, not always RRR. Actually, R is placed, and you are getting the planar molecule here. And attack is occurring from the top or from the bottom. We are getting two different products. One is R, another is S. RS nomenclature. Another type of nomenclature is there for stereochemistry. It is called RS nomenclature. Okay, rectus and sinister. Rectus and sinister. R means rectus, S means sinister. Rectus means right hand rotation and S means left hand rotation. Okay, so this is giving retention of configuration, this is giving inversion of configuration, and we are getting enantiomers. Now coming to SN2, because SN1 I have talked a lot. Last day also we have discussed, so let's come to SN2. So in this case, what is happening? OH- is attacking from the back side and B are going out. We are getting a transition state. Here is also showing this same thing. So the attack is coming from the back side. Yes, from the back side is coming. Just see, back side is coming. Red one is entering, and the green one goes out. But in between, you must understand. In between, there is some situation when all the 5 bonds are there with carbon. So it is called pentavalent carbon. In the transition state, it is in the transition state. It is temporary. It is not a permanent phenomenon. Just going on. The process is going on. That is called transition state. And after that, the final product is achieved. This is called SN2 reaction, and you are getting inversion of configuration. SN1 gives racemic. SN2 gives Walden inversion. What does it mean? If you have some D product, you are supposed to get L. If you have got L product, you get D. So kinetics of SN2, CH3Br plus OH minus, you are getting CH2H plus Br minus, and this is the kinetics. Kinetics means rate of reaction. If just as simply if I tell you what is the kinetics of this reaction, you must understand that is I am asking about the rate of reaction. What is the kinetics? If I just casually ask what is the kinetics, so you have to answer yes, the rate is equal to this. That is the kinetics means rate. So rate equal to K into alkyl halide concentration into nucleophile concentration. Both are involved. Just see, both are involved. That's why it is bimolecular. One molecule is this, another molecule is this. This is the nucleophile. So in the rate equation, both are involved. That's why it is bimolecular. But in case of SN1, only alkyl halide is involved, not the nucleophile. And that's why it is called SN1. But here, you are getting both the molecules involved. That's why it is SN2. 2 for bimolecular, 1 for unimolecular. So differences are already charted. You can go through any time. It is given, I think. All are uploaded. But I think one I have not uploaded. Something is missing. Check. This is the pentavalent carbon, and after that the product is formed. So SN1, SN2, and then let's see what extra I can get from here. All of you understand rate determining step? Could you understand why SN2 reaction will be retarded in presence of polar solvent? SN1 will be accelerated, that you understood, because of carbocation formation which is getting stabilized by polar solvent. What about SN2 reaction? Why it is becoming sluggish? In a polar solvent, SN2 reaction becomes sluggish. So non-polar solvent is preferred. Why? That you could not understand, no? Let's clarify that. You have a structure, okay? So you have a structure. Just a minute. Let me